This is a IIPMT question on electric potential chapter basing on electric potential energy. The problem says two charges Q1, Q2, this is Q1, this is Q2, placed 30 centimeters apart as shown. Third charge Q3 is moved along the arc of radius this way, moved along this way from C to D. What is the change in potential energy of the system is? It is given some value into K, we need to find out that value of K. So, the first thing that we need to understand is here there are two positions, right. So, first I will write when Q3 is at C, case 1, let us calculate the potential electrostatic potential energy. I will draw a quick diagram for us. It is A, this is B as given, this is C, this is given as 40 centimeters, this is given as 30 centimeters, and this is the position. At A there is Q1, at B there is Q2, at C there is Q3. So, to know the potential energy between every two charges there is potential energy. I need to know the distance between these two also. It is quite easy. I can get BC as ABC is a right angled triangle. I can write BC square equal to AC square plus AB square, Pythagoras theory, that is 40 square plus 30 square, that is 50 square. So, BC equal to 50 centimeters. It is quite easy. So, I got this BC as 50 centimeter. Now, I can calculate initial potential energy of the system in this case. U1 as, you know the formula potential energy is 1 by 4 pi epsilon naught Q1 Q2 by R. Between this A and C, you have Q1 Q3 by R is 40 centimeters, but I will write in SI system 0.4. Between A and B, that is Q1 and Q2 by 30 centimeters means 0.3. Between B and C, the charges are Q3 and Q2, distance between them is 0.5 meters. That is initial potential energy, and that is the case 1, right. Now, let us talk about case 2. What is said in case 2 is Q3 is moved from here to a point D where this distance is given to you as 10 centimeters. So, I can draw a new diagram now. Yeah. At A there is Q1, nothing changed. At B there is Q2, that is also not changed. But Q3 is not at C, it has moved to D. So, I have to write there is a point C, but there is no charge at the C. It is moved to a point D where this distance is given to you as 10 centimeters. Of course, this distance is given to you as 30 centimeters. And here is the Q3, this is the new system. So, can I write the new potential at C? There is no charge because charge is moved from C to D. So, the new electrostatic potential energy of system is U2 equal to 1 by 4 pi epsilon naught. Between AB there is potential energy Q1 Q2 by the distance is 30 centimeters, that is 0.3. Between BD there is no BC because there is no charge here. Between B and D Q2 Q3 by 10 centimeters means 0.1 meters. Now, between A and D Q1 1 by 4 pi epsilon naught I already had written. This is 30 and this is 10, together it is 40, that is 0.4. That is the second potential energy. I know initial potential energy, I know final potential energy, then I can write change in potential energy, electrostatic potential energy is final minus initial. So for both of them 1 by 4 pi epsilon naught is common, 1 by 4 pi epsilon naught, as it is u2 minus u1, write all u2s as positives and then write all u1s as minus. So q1 q2 by 0.3, q2 q3 by 0.1, q1 q3 by 0.4, that's all. This first u2 minus u1 I have to write minus q1 q3 by 0.4 minus q1 q2 by 0.3 minus q3 q2 by 0.5. Let us see, is there anything that cancels? q1 q2 by 0.3 minus q1 q2 by 0.3 can be definitely cancelled. q1 q3 by 0.4 minus q1 q3 by 0.4, that can be definitely cancelled because their positions has not changed, their respective potential energy is not changed. That implies change in potential energy is 1 by 4 pi epsilon naught. This is the remaining term, q2 q3 by 0.1 minus q2 q3 by 0.5. That's what we need to find out. Yeah, that is equal to 1 by 4 pi epsilon naught, that LCM is 0.1 into 0.5. So the first term becomes 0.5 times of q2 q3 minus second term becomes 0.1 times of q2 q3. Yeah, let us simplify this. 1 by 4 pi epsilon naught, 0.5 minus 0.1 is 0.4, q2 q3 by 0.1 and 0.5. This 0.1 0.4 becomes 4. This 0.5 on the numerator becomes 2. 2 into 4 becomes automatically 8. So what will be that value? 1 by 4 pi epsilon naught 8 q2 q3. That's the answer. But look at what he has given, that value is given as 1 by 4 pi epsilon naught q3 and k. So in that 1 by 4 pi epsilon naught is there here also. q3 is here in the given question, in the answer also it is there. Here you have k, unknown term. In the place of k, here you have 8q2. So the answer for the k, that implies k equal to 8q2. That's the answer for the problem. That's the first option itself is the answer for the problem. So this is how I have to solve the problem. It's a simple problem, but this problems has to be done very carefully without messing up with positive signs and negative signs. That's a very important thing that you need to follow. That's it, and thank you for watching.